Okay, this video is on completing the square. So completing the square is valuable because it helps us in our quest to solve polynomials, right? So typically in algebra you've seen things like x plus 5 equals 10. Well, what's x? You subtract 5 from both sides and you get x equals 5. Well, with polynomials, you can't quite do that, right? Because you have an x squared. You can't just put the 1 on the other side, and it's still confusing as to what x squared and x is. There's no clear picture of x. So that's the entire point of solving polynomials. We need methods to solve polynomials like this. It's not as simple as a linear term like x plus 5 equals 10. That's easy. This one, the polynomial is hard. So we're trying to get to the quadratic equation eventually, and that's kind of one of the pinnacle ideas of algebra. And this is exactly the basis of the quadratic equation, and the way we were solving this today, you could prove the quadratic equation. So if you don't know what that is, that's fine. Ignore it for now, but let's solve this by completing the square. Okay, so the whole basis for completing the square comes from these special factorization rules, if you remember them. So if you look at a plus b squared, right? If we had something of the form x plus 5 squared, right? That is some polynomial. That's x, if you FOIL that, that's x squared plus 10x plus 5 squared, which is 25. Right? So this is a polynomial that can be reduced to this. And once you have it like x plus 5 squared, you don't have an x squared and an x term. You only have x plus 5 squared. So what if I told you x plus 5 squared was equal to 30? Well, this is really easy to solve. If you took the square root of both sides, let's take the square root of both sides, square root. Well, on the left-hand side, that square term goes away, so you're just left with x plus 5. And that equals the square root of 30. Well, now you have that linear equation, x plus 5 equals root 30. I know it doesn't look pretty, but you could punch this into a calculator and get a decimal. So now you just have x equals negative 5 plus the square root of 30. And there, you solve for x. So if we could rewrite this polynomial somehow in its square term, it would be like 2 steps away from, I'm not saying this is this, but if we were to rewrite this somehow looking like this, we would be really close to just taking the square root and solving for x, right? So that's the whole point of completing the square, is that if we can rewrite something in a squared term, you just take the square root and subtract off the extra number, and you're left with x. And that's a really easy way to solve for x. So that's a really good method. So how can we rewrite this as completing the square? Well, first of all, I'm going to tell you this is a great website that I'm on right now. Let me punch over the URL, mathisfun.com/algebra/completing the square. It's one of the top hits in Google if you Google completing the square, and it gives a great explanation. So use this as a resource. I'll post it in the comments. You can take a look. But I'll walk you through this one. So the first step in completing the square is, it's actually, if we had 2x here, it'd be getting rid of that a term. You divide everything off, but in this case, we don't need to. So again, our goal here is to get it looking like this. So that's why you have to divide off the coefficient of the a, or the x squared term, because you want that a without a coefficient. Okay. Let's keep going. Okay, so we have our polynomial. We want to, the second step is to subtract off this 1. So we'll get x squared minus 5x equals negative 1. And now how do we get x squared minus 5x to look like a squared plus 2ab plus b squared? Well, our a terms, that's clearly our x terms, right? So we have x. So we already have an x here. We want this, so we want it to look like plus something something, and we'll have to add that to both sides. So plus something something, right? To keep an even equation, you can add things to both sides. So we're wanting to add something like this b squared so that it looks like, so that we could use our special factorization rule to crunch it down. So let me move this x actually. So we have x squared plus 2bx plus b squared, right? So what is this 2bx? Well, we know that, well, we want these to be the same, right? So let's look at this. What if we said 2bx equals negative 5x, right? Then this 2b, this is our like b term, right? So we want to solve for what b is so that we can write it here. So let's solve for b. So divide both sides by 2, bx equals negative 5 over 2x. And well, if you divide by x on both sides, the x's goes away, and you're left with b is negative 5/2, right? So if we set b equal to negative 5/2, what this would look like is 2 times negative 5/2, well, x squared minus 5x, and then this b squared would be minus 5/2 squared. And that would equal negative 1 plus what we added to both sides, and this is what we added to both sides, this squared term. So you're going to put this on the other side as well. Okay. So what we did, again recapping, is we said we wanted it to look like this equation, this a squared plus 2ab plus b squared. And we said, well, 2bx has to equal negative 5x. So b is negative 5/2. And that b squared term is at the end, so we added that to both sides. And I know this may not look like it, but now this is a perfect square for factoring the binomial, right? So this is a perfect square. And again, because we wrote it like this, we can rewrite it like a plus b squared. So, well, we said, let me write that down, a equals x. So it's x plus, well, what was our b? Negative 5/2. So let's, I'll just write this. So I know it doesn't look that pretty, but it's actually written exactly in this form. So we can write x minus 5/2 squared. And well, what is this? Let's look real quick. Well, negative 5/2 squared, that's 25/4. And negative 1 is negative 4 over 4. So let's see, that equals negative 4 over 4 plus 25 over 4. Well, that's 21 over 4, right? So let's write 21 over 4. Okay, and again, we're really close to finishing. How do we finish this off? It's just 2 steps. It is take the square root and then subtract off the or add it to 5/2 to both sides. So if we take the square root of both sides, we will be left with x minus 5, and that's root 21 over 4. And then, so whenever we take the square root, okay, we'll leave it like this for now, actually. Generally, we'll put a plus or minus sign, something like this, but let's leave it for now. And then we'll just add this to both sides. And that should be our solution. And again, I encourage you to look over this Math is Fun site. They have, I'll put the link in the comments, they have a geometric interpretation of it. They have an example, and they have the steps. So divide everything by a, move the number term c over a to the right-hand side, and you know, you can follow along with their steps for completing the square. And they actually use the plus or minus sign, which is what I should have done, but I wanted to keep it simple for now. So I hope this helps. Please email me if you need any more help. I'd love to help.